fair. I mean, if it's not covered, it's not covered. What can I say? So let's start with number 4 then. The one that we are both sure we covered. All right. Okay. 2 trees, A and B, are standing on flat ground, 12 meters apart as shown. The tops of the trees are 16 meters apart at an angle A. Oh, okay, sorry. They're 16 meters apart, then that's N there. Then angle A is 50 degrees as shown there. Of course, it's not labeled, but you can see where angle A is, right? First of all, calculate the distance AX. So,
It's a right angle triangle.
we have a right angle triangle. Where do we have a right angle triangle?
Yeah.
This one, right?
So we can use this.
And we are given this angle is
50.
50 degrees. So if you want AX becomes our opposite, adjacent, or hypotenuse? Adjacent. And what else do we have? Do we have the opposite or the hypotenuse?
Hypotenuse.
So car, right? Okay, so cos 50 degrees equals to adjacent, which is AX, over hypotenuse, which is 10. Therefore, AX equals to 10 cos 50 degrees.
Which gives us 6.43.
6.43, okay. Mind if I can also confirm? 10 cos 50. All right, 6.42, right? Yeah. And rounded off to 3 significant figures, it becomes 6.43. Meters. All right, calculate the height of tree B. Okay? What did you... I always encourage, before you even start putting pen on paper or touching your calculator, first think how you're going to solve the problem, right? It's like just standing up and then just start walking, or hoping you're going somewhere. You first decide, isn't it? I want to go to Okahanja, okay. Then when you walk, I'm sure you walk, go ahead in this direction. Because if you just start walking, you can go there, you can go there, you don't even know where to go, unless you know the destination, right? So it's the same thing. What are you going to do? How do you intend to achieve getting the value of the height of tree B? What was your thought?
Because it shows that the top of the distance, the distance between the top of the trees is, what is this, 16 meters.
Yeah, this.
So it must be what is this? The height of tree B must be plus or minus 16 or more than 16.
Obviously, okay. So what was your first step? What did you do first when you were trying to solve this? Because remember, this topic is about trigonometry and triangles. So whatever you have to do has to have some triangle related to it.
Is it a triangle?
No, even if was there a triangle here?
Yeah, there was a triangle.
There was none. We drew it.
Yeah.
There was something which resembled a triangle, and we had to draw it, right? Right? We agree? We had to draw our own triangle.
Me, I'm seeing a trapezium.
You're seeing a trapezium? Where are you seeing a trapezium?
If you remove 3A, it will be a trapezium.
Okay, even if it's a trapezium, good, then what would we do with the trapezium?
That's the point.
That is what?
I was only seeing a trapezium.
And then what happens when you got the trapezium?
Because I knew it can't be possible if you have a trapezium and you don't have the height. At least you have to have the answer. If you the whole
Yeah, maybe if you're given the area of the trapezium. So then what? So what did you end up doing? You didn't.
I lost hope because we don't have it, so I started to remember. But if you were to make a triangle like this, you will cut a triangle.
If you have do a triangle like that?
Like this.
Okay, it will cut angle A. So we'll not know anymore what is the size of angle A.
Yeah.
You said, oh, it sounded like you got an idea. What happened?
If it was something like this, then we would have adjustment, but we wouldn't have the angle.
We wouldn't have the angle, right? So that is not a good idea, right? Mm-hmm. All right. So your idea was, let's remove this. So we're done with this, yeah? Mm-hmm. You have to think through yours. Huh? Mm-hmm. Utapovi's idea was to do like this at some point. But then doing like that, now we don't know this. So at the end of the day, we can't, it's useless now because we don't have an angle, we only have one side. Okay. So that idea is buried in the dirt. We never want to hear it again. Beta V, talk to me.
What if you minus like 16 minus 12 and then your answer plus it by 10?
Okay. Trying to minus 16 and 12, yet this is slanted like this. This is straight horizontal. So I don't know what you will be trying to achieve.
16 minus 10. Slanting.
They are also not slanted the same, so I don't know what you're trying to achieve by minusing that.
You minus the 12 and the one that you got it. Oh, okay, 12 minus the answer you get by 3a. Because now we can use Pythagoras theorem. We
can use our Pythagoras, okay? Which triangle are we going to use for Pythagoras theorem?
The right angle triangle.
Which one?
Triangle AX.
AX? Yeah. Okay, so that triangle will come from here to there, and then?
And then go up to 3a.
Go up to 3a?
Yes, and we are trying to find the height of 3a.
Okay. Great. All right, so since we now have this one, which is 6.43, but were we not able to find the height of A even without 6.43?
What was it? Yeah, we can.
We can, right? Mm-hmm. Because we can still use SOHCAHTOA, right?
Yeah.
Is it not true?
It's true. Mm-hmm.
Okay, so let's use SOHCAHTOA to find the height of 3A.
But why not Pythagoras? Pythagoras is really
interesting. They are both the same.
The last time the angle was wrong.
Also, you are thinking this one, the angle might be wrong.
You never know.
Okay, so let's use Pythagoras, okay, as you said. Right, so with Pythagoras, what are we going to say?
10 meters squared equals to?
10 meters squared equals to?
6.43
squared
plus A.
Plus the height of 3A, yeah? Let's call it opposite squared. So we're trying to find this. Okay? Then what? 100 here? 6.43 squared, what do you get?
6.43 41.3.
41.3.
41.344.
41 we said we try to round off only when we are like done with the answer, right? 3,449 plus O squared. Then what?
We take the 41.
We take the 41 the other side.
Then you square your answer.
Root, what is our answer there? 58.6551. Okay.
And our answer is 6.658. We round it off, becomes 6.6.
All right, so we now know the height of tree A with 6.66. So how is it helping us?
Okay, you're gonna take the 12.
Mhm.
12 minus 6.66.
Okay, how are you minusing a horizontal length and a height of tree A? How is that even? Why? Why are we even doing that? Beta V, come on. I know you can do it, man. You guys are playing with me, right?
No, you're not.
You're not?
Okay. So the hint is that the 16 meters somewhere.
The what?
The 16 meters somewhere involved in getting height.
This 16 meters has to be involved somewhere. Even the 12.
You just you take the
But then the way you're involving it is the wrong one.
you take the 16 and the 12 and you add them together.
Look, the hint here, the hint.
Uh,
We agreed. The way you think about maths is this. Maybe when we were doing all these lessons, I was not teaching you how to think mathematically. When you read this first question, the first part, two trees A, B are standing, what, and even when you saw the diagram, the first thing that must come to your mind, because this is how maths works, the first thing that must come to your mind is, which topic is this about? The good thing is, when I opened the questions...
I remember this question paper, the one that was talking about the buildings, right?
Uh-huh. Yeah, so let me continue. The first thing that comes to mind, even if I did not show you what topic it was, right? Just by reading, your first task as a math student is to be able to place what is this question, which topic is it referring to? So why is that important? Why do you need to know which topic you are dealing with when you are reading a question? For you to know what formulas am I going to use, and that particular topic, what kind of questions do they usually ask in that topic? Because with maths, if it's trigonometry, you know they're going to ask distance, they're going to want you to use SOHCAHTOA, they're going to want you to use Pythagoras theorem, right? And those are the only things. There's nothing else that you do in trigonometry except for that. Using SOHCAHTOA, using sine and cosine rule, and using Pythagoras theorem. That's it. All right. So now your mind is clear. It's trigonometry. Maybe you forgot to say trigonometry in your head, but now at least you know I need to be using SOHCAHTOA, Pythagoras, and what. What else do you have to think in that particular topic for me as a student to be able to use all those things? You know, SOHCAHTOA, Pythagoras. What must be present? There must be a triangle, right? Whether it's a right angle, triangle, whatever, but everything that I'm going to work out has to involve what?
A triangle.
A triangle. Okay, so when we did question A, was it easy to see the triangle?
Mm-hmm.
Yes, it was very easy to see the triangle. So now when you do question B, your first question is to ask yourself, where is my triangle?
Okay, now triangle can be drawn from the angle B going down, but it will be cutting angle B. Like,
is that the only place where you can draw a triangle? Thank you, you're coming along. How else can you draw a triangle? Talk to me. Sure, look at the trees. Look at the distances. How else can you draw a triangle there? So finding the triangle is like knowing that I want to go to Okahanja. That's your destination. How else can you draw a triangle, guys? Come on. Remember?
oh, okay. Triangle is like, isn't this also a triangle?
Okay, that can work, but it's not gonna be it's not gonna be useful, because remember we want the height of a tree B. Mm-hmm. I like the fact that at least we managed to find the height of tree A, which is good. But what is next now? I like the initiative that you are willing to put a line there. How else can you draw a triangle? Something that can be useful to us. Remember, what do we want? What are we looking for? Which one is height of B?
This one.
That one, right? Okay, good. Which other way can we draw a triangle? Come on, man. Okay. Topol want us to go this way. Okay, how is that going to help us? They're not wrong ideas, they're not bad ideas, but then the next question will be, okay, now that we drew it, how is that going to help us? Remember, sometimes the triangle doesn't give us the answer immediately, right? It will just help us to get to the answer. Yes, so don't expect the triangle that we are going to draw to immediately give you the answer. It might just be a step towards the answer. So now that you have that knowledge, can we try another triangle? Once I draw the line, you're going to be so mad at yourselves.
Oh, don't.
For taking this long to figure out what is the triangle. Okay, I give you another hint. The fact that you decided let's find the height of A was a very smart choice. Now you just need one more step to get to the height of B, the answer that we want. But you need to draw just one line that will make a nice triangle that will help you now achieve your goal. That's more than a hint. That's like,
What about something like this?
we already talked about that. We already talked about this. Like, okay, if we draw like this, how is that going to help you?
You think this is a triangle?
Yeah, that one is not helpful because we now already have A. Because if we draw this line, it means we are talking of this triangle, isn't it? Or which triangle do you want with that line?
This one.
Okay. Maybe we're going somewhere. Let's see. It's starting to be interesting there. All right. Beta V wants us to go like that. All right. So how is that going to help us? We have that triangle. Then what? All right. Let me help you out. One last chance?
Yeah.
Okay.
One last with a hint.
One last hint. Okay, one last hint is that it was so good that you calculated the height of A, 3A.
So 3A is also part of this triangle.
No, 3A is not part of this triangle. But 3A is part of the height of 3B.
I know. So it's just 6. I know the 16 centimeters based on what they. What about?
Remember, we're talking of height, right? So you're saying 3A is also part of 3B. So now in order to get 3B, you just need to get the extra height from the top of 3A going up to the top of 3B. That's another hint. That's the last hint I can give you. Because now I'm giving away the
How
answer.
I calculated my views, and I thought it was wrong.
Let's see.
6 minus 12 is
16 minus 12, yeah, that one is definitely wrong because there is no way they can relate 16 and 12. You are not gonna subtract those because 3A and one is slanted and one is horizontal, so you can't subtract those heights.
just give us the money.
So that hint was not useful. The fact that from top of 3A up to top of 3B, that's all you need to find.
Oh, I know.
Exactly! You you're just supposed to draw a line here,
Yeah.
a line here, and you know it's horizontal, so you know this distance already is 12. Now you have 12 and you have 16, you just need this part.
And then you're just gonna use
Just use Pythagoras theorem. Thank you. So 16 squared minus 12 squared equals to that part,
16
which you can call O squared.
minus 12 squared. 112.
So 112 equals to O squared. So root 112 equals to O.
10.58.
10.58.
10.6.
Okay, so we now know this part is 10.58. This part we already know is what?
So it's 10.5. 6.66. 10.58 plus 6.66 is equal to 17.2.
17.2. Was that so hard? Just one line. Come on, guys. I thought it was like so there, especially when you decided to calculate the height of A. I thought, okay, we are definitely going somewhere. Because that was the only clue there that you needed. That, okay, if I get A, and you notice that we talked about having to do triangles every time. So you see, our question was solved by triangles because it's a triangles topic. Trigonometry, we agreed, try for 3. So whatever you're going to be doing, it has to involve a triangle. If it's not involving a triangle, then something is not right somewhere.
Calculate angle B.
Okay, so you were saying angle B was difficult. So now is it possible to calculate angle B?
It's very possible.
Okay, so calculate angle B for me, both of you guys, quickly. Because I'm sure now you can see there's a triangle. You have more than 2 sides. In fact, you actually have all the sides now.
It's 48.6.
48.6. Okay, so angle B, I can use any method I want. So car or toa, I'll use opposite and hypotenuse. I will use sin B equals to 12 over 16. So B equals to sine negative 1, 12 over 16. Veda V, I want you to use tan to find angle B. Remember we're working with this. Okay? Don't forget your triangle. There is our triangle. And you know you have all the sides. So I want you to use tan. But I'll probably use cos, please, to find angle B. I want to see it in writing. So, 48.59, which is 48.6. We're getting 48.6 degrees. Write it down before you punch it in the calculator. I want to see what you did. The same way I did mine here. I start by stating the ratio. and then finding the inverse. Those are the steps that I need to see. Guys, you can't take forever with this. Alright, so the one who used 10, I need opposite 12 divided by adjacent, which is 10.58. Okay, so it's funny that you're saying no wonder. What is 16 in our triangle here? Is it the opposite, adjacent, or hypotenuse?
It is not the hypotenuse.
It is the hypotenuse. But what is it doing in a tan question? Tan is tau. Is there anywhere where you see hypotenuse there? Toa, sorry. Thank you. Tan is toa, opposite of adjacent. So you can never find a hypotenuse there. So you can't have it. Ka, I expect to see 10.58 divided by 16. It's giving you 48 as well. Alright? Now, are we getting a correct answer now? Excellent. So, can you see the process, guys? Identify the topic. You know you're going to be dealing with triangles. So if your question, if you can't find a triangle in the way you're going to calculate, think again. Try to find the triangle. That's all we did on this question, isn't it? And it turns out, oh, it's easy after all. Or am I missing? Is it not easy after all? It is, right? Let's see. The one that was said, no, we did not do it bearing like this because the ones that we were doing were so easy. Okay, let's see. Let's start. We'll get my ruler here. Where does that ruler disappear to all the time? Okay.
I just forgot.
Mm-hmm.
My sister said I should come and give you.
Oh, okay. Thank you. I hope your mom is paying for something that is worth it. Is it? Okay. A boat starts at point P, right? We don't know what point P is, but we can just decide, we can just put it, but we already talked about this, how math is a lot of English, right? Okay.
My question is east always right or left?
Okay. I think we talked about this another time, where I asked you to draw a compass. Then I told you that east is always going to be to the right of the north and south line. So you're gonna your compass is always gonna look like this, right? North, south. That one is easy, right?
Mm-hmm.
So once you have that, always to the right is your east. No. Always to the right is your east. Yeah, so that's east, right?
That's what I said.
Oh, that's what you said. Okay, if that's what you said, then we are on the same page. There you go. In case you forget, think of how, you know what a world map look like, where Africa is in relation to other continents like America and stuff. Okay. Let me show you how to remember it in another way. Let's say world map. I'm sure you have heard that when we talk of countries like America, instead if we say the West, countries in the West, countries in the West. We always say that, right? You hear that, right? So look where Africa is. Africa is here, right? And to the west is where? To the left. You see, Africa is here. Let me open nicely here. Guys, Africa is here. So you know already top, north, bottom, south. Countries that are to the west, the easiest one to know is United States, Brazil, they're to the west, right?
United States.
No, there's one, but I mean, yeah, they like owning everything, so yeah. To the west, to the west. So already you can see that it's west is always on the left side, and then eastern side, China, India, something like that. So the same way you are seeing it on the page is the same way that your campus looks like, isn't it? So always to the right of your north and south line is your east. To the left is west. Okay. So did that have any influence? Did you draw it correctly?
Yeah.
All right. So it means it didn't bother our things, right? All right. So let's start. A boat starts at point P and heads due north for 20 kilometers. Okay, so I'll assume that point P is maybe, I'll just put it here. What does due north tell me? It went up, right? Okay. Let's see. Okay, so I'll just say that is the 20 kilometers until point Q. So I'll call this point Q. At Q, it heads east. East means it's going to go to the right, right? Okay, whichever way. I would actually make it a bit smaller because it's 15 Ks. Okay. So it went 15 kilometers east to point R. So that's point R. At R, it heads on a bearing of 0.45 for 10 kilometers to point S. Okay. So there's nothing weird about having a 0 at the beginning. It just means it went 45 degrees. All right. So what do we know about bearing? What did we talk about? We always draw the compass where it's coming from, right? It's 45 degrees from R. From R. So we're going to have our compass there. Right? That's our compass. We agree? And then we draw 45 degrees. That 45 degrees, what did we say it must come from? It must come from the north, right? Then you measure 45 degrees. Okay. So what does that mean for us? It means you just want, remember, this is 90 degrees, right? This. So 45 degrees, you expect it to be right in the middle, right? So that this angle is what?
45.
Okay, so that's our point R. And then, so when it started going like this, it went for 10 Ks. So we assume point S is there. Is that the diagram you have in your book? Where did it go wrong if it's not the one you have in your book? Which language was Shona? The language is Shona. Which language was Shona that you couldn't understand?
Shona. I just got lost at 45.
Okay, tell me, how did you get lost at 45?
We could read the English and everything, but then sometimes you can read what is going on there, but then just to understand.
Okay, the only way for you not to understand is if the language is something that you don't understand, right?
No.
Okay, let's start again. Both starts at P.
No, but then when you read it and did it, I did understand.
What do you mean? You see, okay, I like it. Okay, so, all right, Utapovi got here and got there, but then she went down and decided that this is 45 degrees. You decided, right? Because I'm sure now that you can see it can't be 45. It's actually 90 because I can see your S is going due south. So at what point did you decide that I have to just make it? Did you just want it to go down or what? What was happening? Were you just trying to make your graph go down, sort of?
I don't know.
We talked about bearing. How do you calculate bearing?
No, but then let's say bearing you calculate. Let's say if you say what is let's say if you say calculate the bearing of A from B.
Yeah.
Then you draw your
compass, and then you measure from the north leg, right, going to until you reach that amount that you want. So how was that not leading to this? It's not practicing, right? So can you say it because we didn't do it?
It's not practicing.
But I'm really fascinated. At what point was this English so difficult, guys? Come on, man.
It was not difficult. It's a difficult person like me not practicing. Just 45, and then I just decided to draw a 90.
You just decided to draw a 90-degree angle. Okay. So anyway, there is our graph. That's the correct graph there. And you see, once you have the graph, things become just straightforward. Anyway, the last number is here. It's 10 kilometers. All right. So that's our... Now, first question is... calculate the vertical distance between P and S.
For A was just asked to draw.
Yeah, there is a question, sorry. P. With the aid of a sketch, if necessary, calculate the horizontal distance between R and S. Okay, so which one do you think they are referring to?
R and S.
So if we extend here and extend there, we'll have a nice 90 degrees, right? And remember, if this is 45, this is also. So they want the horizontal distance between R and S. So they want which distance?
Yeah.
This distance. Okay? Is it possible to get it?
Mm-hmm.
What do we have?
We have 10 kilometers.
Which is a adjacent, hypotenuse or opposite? Hypotenuse. Right? I hope you are watching us, what we are doing, and then I'll give you enough time to write. We have to get this. Calculate the horizontal distance between R and S. Look where our S is. Look where our R is. How did I end up with the horizontal distance? I extended this line and extended a vertical line from S. So that at the end we have a 90 degrees. That's how now the 10 ended up being the hypotenuse, and that horizontal distance between R and S becomes our, given that our angle here is 45, because the bearing that we got is 45. Obviously, since it's a 90 degree, it cut into half, so this one has to be 45, right? So now that we have an angle here, 10 because of its opposite, the 90, it becomes our hypotenuse. The horizontal distance that we want becomes our adjacent, right? So hypotenuse and adjacent means car. All right, so cos 45 equals to adjacent over hypotenuse. So 10 cos 45 equals to A. Seven 7.07 kilometers. So the horizontal distance between R and S is 7.07, this one. Done for that one. Part 2, calculate the vertical distance between P and S. P and, again, we can simply just extend S, right? We can extend if you want, if that's going to be useful. Let's see. So P and S, it means what they want is this distance, right? First of all, do we agree with that?
Yes.
Vertical distance between P and S. So you know that P and S are not on top of each other, but they can have a vertical distance. First, how do you get it? To extend this line, and then we'll find that vertical distance. So what we want is what I have represented with that long black arrow, right? So how do we get that? So already for this part, do we know it? We already know it's 20, right? So we only need which part? This part. And to get that part, we can still use that same triangle, isn't it? That we drew already. Soka, to, or a, or Pythagoras theorem. What are we going to use? Beta V, ammonia.
We can use it. We can use the soccer to, because we don't have a triangle.
We have.
But we use the same triangle we use.
Beta V, you need to follow us here. We said what we are going to calculate is what? This whole length. Do you agree with that, first of all?
Yeah, I agree with it.
Okay. Do we have this part?
Yeah, we have that too.
It's 20, right? So what do we need? We only need that part. Do you agree with that? So in order to get that part, we are not going to concern ourselves with the whole picture. We're only going to concern ourselves with what? With this triangle. Why? Because this triangle can help us get which? This height, isn't it? Can that triangle help us do that?
To get that height.
Yes. Can that triangle help us get the distance from here all the way to here? Is it possible to get that height using this triangle?
How?
What do you mean how?
This part and that part of this whole triangle, then this should bring be a triangle. So if this part is here, it makes it a triangle, so it might help us. Can you see what I'm saying? This part of the triangle must be the hypotenuse and the other side. Aren't we supposed to find this distance?
Yeah.
And we already have a 20 kilometers. From where?
Look, the only reason why I drew this line on the side is so that it doesn't interfere. But let me remove it. Maybe that's why it's confusing you. Let me remove it. There, it's off. Now, we are saying the distance, the vertical distance between P and S is. Let's actually just start over. Let's remove this. Okay. So you know S is here. The vertical distance between P and S is this whole length, right? You agree? Do we know from here to there?
It's the same as this one.
Which is 20, right? So what we need is only this part, isn't it? This one. And that line is part of this triangle, is it not? Are they not together?
Yeah.
You agree? So if they are together, are we able to find this distance? Because we already know what is the side, the length of this side. We already know also this side is 10. We already have an angle. We can have a part as to which method we are going to use to find that the length of that side, is it? So which method do you want us to use to find the length of this side, this part?
Here we have the adjustment.
7,
Then here we have
hypotenuse.
the hypotenuse.
We even have an angle.
So we can adjust the hypotenuse. We can use, what is this? I'm checking your book.
Okay, check in your book. So car or tower, which one are we going to use?
Car.
Car. Okay. Car, is it going to help us? Because look, the way the angle that is given is 45 here. So with car, you need adjacent, which is the 7.7. The hypotenuse, which is 10. So it's not going to help us to find this. You need something that is opposite to the angle. Because look, the given angle is this one. So what the side we want,
we use either tan or sin.
we can use either tan or sin. So which one do you want us to use?
Sin.
All right. So what is it going to be? Sin 45 equals to
adjacent or adjacent. Opposite of our hypotenuse.
all right. Do we know the opposite? That's what we want, right? What is the hypotenuse?
Hypotenuse is 10.
10. That's it. Because we want this. Because we want to know what is this part. And add it to the 20. Okay. So 10 sin 45 equals to O.
It's the same.
Is it the same? 7.07? Okay. I want you to tell me why is it the same? Utwapovi, tell me why it is the same. You are almost right. You are actually right, but you are just not confident. Because you know I was going to ask you, why do you say it's an isosceles?
Oh yes, it can be an isosceles. Yeah, it is an isosceles.
Okay,
If
why?
you turn it sideways, like if you turn it this way.
Okay, even if you don't turn it, it can still be an isosceles. But
But
why did you agree that it's an isosceles?
Yes, two sides are equal.
Okay, assume we didn't know the other side. We didn't have this, the 7.07. How else are we supposed to know that it's an isosceles?
Because of the angles, I don't know.
Okay, what about the angles?
45, 45.
What makes you say that the other one is 45?
Because it's a 90, it came out from a 90 degree.
Thank you. So if this one is 45, the other one has to be 45. Because it's a right angle triangle. If here it's 90 and you're told here it's 45. So in order to get to 180, this has to be 45. So whatever you have here is the same as whatever you have here. So even if we did not calculate, we didn't even need to calculate. I just calculated so that we can talk about this now. But we didn't need to calculate. Right? Because if you have a triangle like that, and I tell you 45 degrees, and then I tell you this is 10, this is 15.
It's so bad about that 45 and then this is already 90. So the other side for you to make it a 180 has to be 45.
Once you have a 45 degree angle, the other one has to be 45 because you have to get to the other two must give 90, then the other one must be 90. So we didn't need to calculate because once you know that the angles are going to be the same, the sides were definitely going to be the same. That's why that question is just a simple 2 marks. We didn't need to do anything. So now that we know it's 7.07, so we now know the distance is
27.07.
okay. But just in case you're going to argue with me, how are we saying it's 0.7? We calculated it. But now I'm just telling you, if it's 45, one angle is 45 in a right angle triangle, immediately you have an isosceles triangle. There's no other way, isn't it? And it only works with 45 because 45 is the only one that is half of 90. Right? Talk to me. Number. Calculate the shortest distance between P and S. Okay? P is here at the beginning.
When you slide your line from S and down to P.
Yeah, so they want this whole distance.
Okay. So I already have a 20 and 15 kilometers. I have to find P and R. Which will isn't PR also 20? Remember when you're doing the parallelogram whereby the slant side, remember when you were confused?
But here where it is trigonometry, so we're only dealing with a triangle. So
But no, remember when you were confused?
already this is 90, you have your 20, you have your 15. What do you call this side?
The hypotenuse.
The hypotenuse. So how do we get it? We don't need angles.
Oh, by circular theorem.
Okay. Are you together with us or are you agreeing with us? There is a triangle.
I saw it.
There is that side, there is that side. The side which is opposite the 90 degrees always called the hypotenuse. So?
We get 25.
Alright, so this h equals to root of 20 squared plus 15 squared. So you get 25. Okay, but that's just half job done, right? Yeah. Because now you know this is 25. Do you know this other part? From R to S, we know already that is 10. So what is the total distance?
25 plus 10 gives us 35.
We know 25 and we already know that this is 10. Right? R and S. Heads on a bearing of 45 for 10. So we know it's 10. 25 plus 10 gives us
35.
all right. Calculate the bearing of S from P. S from P.
So we'll be drawing our compass with S.
From P.
From P.
So which angle do you want? So obviously if we come and draw a compass here, what we just want is that angle.
45.
Are you sure?
It's not really 45.
Yeah?
It's not really 45. So because we have a right angle triangle, we have all our
Sides.
yeah, we can calculate. So we are trying to find.
Right.
So
I want
we have that
you.
angle also.
I want you to get it using tan, and you use cos. So let's start with tan. Use tan. Look at your triangle before you even touch that calculator. Look at your triangle. Look at the angle that you want. Decide which one is your opposite and which one is your adjacent, and tell me what we're going to do.
The opposite, the angle I want is this mistake.
The one that I marked with red, okay?
So
It's going to be tan.
my what is this?
Tan angle equals to, tan is toa. So which one is your opposite?
Opposite is
You can say the
opposite
number.
is 15.
15. Which one is your adjacent?
Adjacent is 20.
20. Excellent. So tan negative 1, 15 over 20 equals to,
There will be 6.8.
you see, that's why they even said to the nearest degree. So you mean you are rounding it off completely, making it what? They want it rounded off to the nearest degree, meaning as a whole number.
I'm getting 53.
Letter V, can you round off that number to a whole number? I don't want decimals.
To a whole number.
Without point something.
So it's 37.
Thank you. You look at 8, it makes it the 6 hours 7. They say to the nearest degree there. So they want it as a whole number degree. All right. Above V, it's your turn.
So it's, you said I should use car.
I said you should use car. So cos of our angle equals to
20 divided by 25
adjacent
over hypotenuse.
over hypotenuse.
You bring the cos, this side becomes
Cos negative 1,
20.
20 over 25. Okay.
Giving me 36.86.
I thought you said you're getting 50 something.
No, I know. First I was using the opposite over. I was using.
We are still making those mistakes with soccer tour, guys. I thought by now soccer tour is like
No, it's just.
part of our family. Round it off to the nearest degree.
Giving me 37.
Each. So it doesn't matter what you decide to do, tan, cos, sine, you always get the same answer, right? So that's number 3 for bearing for you. So is it something that we did not do? Or it all started with you not sketching the thing correctly because for some reason that English was so difficult, very, very difficult.
And give us one last try.
I'll give you one last try. Okay. We just start anyway, and we start by having a point which represents our radar station. I'm gonna call it R. Our radar station. All right. Now they said.
So in cases like this, is it possible to use a protector?
You don't need to.
Just to make sure that the angle.
But remember, the angle on the paper is not going to help you than the theoretical angle. That's why most drawings are drawn to scale. It's even saying make a scale drawing. Because the theoretical answer doesn't matter. You just need to apply the correct principles of the compass, right? So let's see if we apply the correct principles. Are we together there? First thing, our points are simple, right? Just put a point anywhere you want. There's no rule there. Now, the next thing is saying, they pick up a distress call from a ship. It is 50 kilometers away on a bearing of 345. So it's a bearing of 345 from the station, right? That ship is 345 from the station. So we're going to draw from the station. That's where we're going to have our compass, right? And if you look at, let me remove this for now. Okay, there's our compass. Our compass will have north like that. So we want 345 degrees, right? So if I start with 90, 90, 90, that's how much? 270. Okay. So that is a known truth. You can't deny that, right? So if I want 345, I've already covered 270. How much more do I need?
75.
Okay, so what I know is that I'm going to have a 75 degrees here. So, what do I know? I know that this will be, we can't argue that, right? You agree with me, and according to the diagram, that's true. Okay, so we know that's where the ship is. So we can just say the ship is there. And that distance is 50 kilometers. So far, we agree? From the same position, that radar station, we contact a lifeboat, which is 20 km away, on a bearing of 220. Okay? So 220, we start again, 90, 180, right? So 90, 180. So let's subtract 220 minus 180. So we need how much more?
40.
All right. So we know it's going to be going in this direction. Okay. So we know this angle is 40 degrees, right? Are we together? Are we agreeing there? All right. So the first question I want to ask,
I know.
what is this angle?
50.
Do you agree?
No.
Do you agree that this angle is 50? What is this angle?
50.
50? How did you get it?
Because this whole angle is 90 minus 40 is 50.
All right, excellent. So we know this will be 50 degrees. So our lifeboat is somewhere here. Okay? All right, so that's what we have. So altogether, what is this angle? This big angle that is opened up?
125.
This one. Ravi, we're talking about this one.
125.
How did you get 125?
50 plus 75.
50 plus 75. So this angle is 125 degrees. Okay. So we all agree on that one, right? So now, so far that's what we have. So far that's what we know. So what they are asking now is find the distance and bearing of the ship from the lifeboat. So what we want is that distance.
So you have to use the cosine rule. Huh?
Is that what you want us to use?
Yeah.
Is that what you want us to use?
Cosine. So we can opposite and
Tell me what you want us to use. 20 Ks? Here it's 50 Ks. We want that distance. Should we use cosine rule? What if we try to use Pythagoras? Do you think it will work? It won't, eh? Okay. So, cosine rule for side, right? We call it side A. Let's just call it A. So we know that A squared equals to 50 squared plus 20 squared minus 2 times 50 times 20 cos 125. Do you still even remember the cosine rule? Yeah, I can see that face. That face is someone who's not practicing. Surprised, what is the cosine rule? That's our cosine rule. And we said, cosine rule, it's easy to recognize where you need to use it. How? With cosine rule, this is what you must just look for. You must have an angle, and the two sides that are given must be right next to the angle. The sides that are forming the angle, right?
But isn't it doesn't it mostly apply like when calculating a non-right angle triangle area?
Yes, cosine rule only works on non-right angle triangle. But my point is, how do you know whether to use cosine rule, whether it's going to work or not? Because maybe sometimes it's difficult to know, is it going to work? So the only easiest way to know if cosine rule is going to work, you must be looking for it must be a non-right angle triangle, and the two given sides must be the ones forming the given angle. So that's how you know I need to use cosine rule.
What if like we were given side A but we didn't have 50 kilometers?
Then cosine rule was not going to work.
And what rule would work there?
Then we would try to use sine rule if there is another side.
Yeah, I have the sine rule.
Yes.
Okay.
So cosine rule for side
So
only works if the two given sides form the given angle and the required side is opposite. The angle. I don't think it's a difficult rule to remember. The given side that you are on, that will be on the picture, whether it's going to be in bearing type or in any question, they must be the ones forming the angle. And the side that you want must be the one that is opposite that given angle. Like in this case, the side we want is opposite the 125, across or opposite. So like in this case, okay, so you have side 10, side 15, they are forming the angle theta, and what you want is length of A, which is the one opposite to the given angle. So when you see a situation like this, you know without quick thinking about it, cosine rule for distance.
So what if we were given side A, but we didn't have the 50 kilometers, or an angle that only had that angle, the 125, but no angle, only that one angle.
And then
We didn't have any other angles, just one angle, and we're given side A, and then 15, and then 20 kilometers.
Okay,
Then
so
find 50 kilometers.
okay, so let's say you are given A, so you are saying you are imagining a situation where you have 125
And A.
and you have A, maybe it was 10, and you have 15. You don't have 15.
We have 20.
You have 20.
And we are trying to find 50.
So we want to know what is this one.
Yeah.
Okay. So in that case, can you see that we can easily use, we can probably use sine rule, but it's not going to work here. Because sine rule, yes, you have this, but you need the angle, this angle, in order for it to apply here. So what you can do is, you can use sine rule to find the angle for here. It will be two-step, because this side we have the length, right? So you use sine rule to find this angle first. Once you get that angle, you now have two angles which will help you find the next angle. Because once you have two angles, you can subtract from 180 to get the final angle. Once you get this angle, now you can use sine rule again to find this side. So it will be a multi-step process, but it will use sine rule. Because sine rule works when there is at least one ratio that you can come up with, the ratio of an angle and a side.
Oh yeah, now I'm getting it. So it would be like we are trying to find an angle, so it will be maybe.
Yeah, we're trying to find, in this case, we're trying to find distance,
So it will
but
be 125 over 10 equals to.
yeah, equals to sine theta over 20.
Yeah.
So it will help you get theta first, so that you find this angle, and then from there, subtract from 180 by putting these two together, get this angle. Then apply the sine rule again to find this side now.
Yeah, what if it was not 20?
Why are you trying to make life difficult?
I'm just no.
If there was not 20, then that question was impossible. So they have to give you sufficient information, yeah, to make it possible. Okay. She's looking at all possibilities, which is good. Okay, so this rule was sine rule, cosine rule, we are done with it. We can't complain.
Yeah.
All right, so can we finish off this one?
Yeah.
So a squared equals to, what did you get?
I got 54.6. No, the A though.
Yeah,
I already squared my answer.
I always encourage you to put that whole thing in there. There is no point in trying to go step by step. 50 squared plus 20 squared minus 2, 50, 20, cos 125.
And my answer is 1.
So 4,047.152. So final answer will be A equals to square root of that. $63.6. So the lifeboat is 63.6 kilometers from the ship itself. Is that okay?
Yeah. And then we move to here.
The next question is, what is the bearing of the ship from the lifeboat?
So we draw compass 70
We draw a compass where?
at the last foot.
At the lifeboat. So we're gonna draw a compass. So I'm gonna delete there just so that we can be able to draw a compass. Our compass will look like this, right? Do you agree? Now we need all the way there. Right? Okay. So the first question you ask yourself, we want this thing to be as accurate as possible so that you can see the big picture. So in order to calculate this angle, remember here we will know it's 90, 180, 270. So what we just need to know is, what is this part? What is that part? But that part, how do we know it?
Just 190.
How big is that part?
The whole part only where
Only this part. Only from here to there. Because once we get that, we add to 270 most. Then we get the total bearing.
Like from that line.
From this line
to that line.
to that line that goes to the ship. Just that part. Because we know already this is 270. This one we don't have to worry about it.
Not from the black line to the black line. Just from the black line to the blue one.
So
Let's reverse. Yeah.
even look here, this is 40, definitely 40 based on here. So we get 40 here and it might be also 40.
Yeah, which one might be also 40? That line. Are you seeing which line we want? Remember we said the bearing that we want is the whole black, this one, this whole one, right? But we don't need to worry about these first three because we know it's 270.
I know. I'm asking, is it from this line to this one?
To the blue one.
Okay.
Yeah, to the blue one, because the blue one is the one that joins the ship, right? Not the black one. The black one is the true north. So the true north is not really going to help us here. Or maybe two. So, what do we do?
We have to use that 40 somewhere.
We have to use that 40 somewhere. I agree with you. But how do we use it? So look at this. I extend it like this so that you see that the angle is there. There is an angle here. It's very small, but it's there. Right? Now, let's talk. If this is 40 and this line is like it's showing true north, right? And I also drew a true north here, which is part of our compass, right? So those two lines are parallel, right? This line and this line. They're parallel. So if this is 40, this one will be
40.
Very good. Okay, so far.
Oh, it's a Z, okay.
Yes, it's a Z angle. Now, if we know this 40, and what about if we know this whole angle? Do you think we'll be able to know this small one? Okay, I ask again.
If we know the whole angle.
Yeah, if we know the whole angle, this one, and we already have 40, we'll subtract the whole angle minus 40 to get that small one, right? That tiny one. All right, so now the question is, how do we calculate the whole angle?
Because those are two different quads.
I will extract it. I'll just remove the triangle back again. And say, the whole angle that we're talking about is this one. Remember, this is already 125.
Oh.
Remember, now we already know this is 63.6. We already know that this is 50. We already know that this is 20. So I was able to calculate this angle, theta.
We can use the sine rule.
We can use the sine rule. Okay.
So it'll be 125
Sine 125 over 63.6 must be equal to
50
sine theta over 50. So sine theta equals to 50 sine 125 over 63.6.
Sine 125 over 63.6.
So yeah, so theta equals to shift sine -1 of 50 sine 125.
Why are we using sine -1?
Because we want the angle, don't we?
Oh, the sine means the other side of it.
Over 63.6. 40.
So in the
I'm
base,
getting a math error.
You're getting a math error.
I'm just saying, change distributions.
So it turns out that that ship was actually right due north of the lifeboat already. Because if our calculation is giving us this angle to be 40, it means this line is actually straight, it's not slanted, as our picture is showing. Okay. So it means our drawing was not nicely accurate. In other words, our drawing should have gone like that, true north. The calculation doesn't lie. So it was already 40 after all. So if it was already 40 after all, it means the ship is directly vertical from the lifeboat. So it means this whole angle is 360 degrees. Because it's directly vertical. It's not at an angle, it's like right on top. If I say calculate the bearing of A from B here, and I tell you that A is due north of B, what will you do? What answer will you get? Bearing of A from B. And you're told that A is due north of B.
360.
It's 360. That's what we have here.
So our answer is 360.
Our answer is 360. And it came to light that it's 360 because when we calculated, we got a 40. So the only way for there to be a 40 here, at this angle, and remember we already have a 40 here, so it means this line had to be parallel to that one. So both had to be due north. That was our evidence. Okay? If this value had been 50 or some other angle, then we will know this line would have been slanted somehow, going like this. But the fact that it gave exactly 40, for it to become 40 here, 40 there, it has to be due north. Okay. So, I can say that one was a little bit tough, but just a little bit. You get time to rewrite. Let's just do number 3. And then you can, I think there's not so much rewriting, it's more just fixing what you had already started. Okay. Let me see the diagrams there. Aircraft, and what is this? It's just a line somewhere. Okay. Diagram.
That's my last drawing that.
Aircraft. What is this? B. A. 35? What is the number? What is their number?
Yeah.
35. Okay. And 125. 125 is for this part.
No. I think it's for here.
The whole thing.
No. It's like
Just from here to there. It's a drawing.
This thing now.
It's a drawing. All right, let's start. An aircraft is seen on a radar at airport A. So we start with airport A. Letter V. Drawings and English, they come together. Read for me from the first sentence.
An aircraft is seen on a radar on airport A.
Okay, so I've got A and I put a point. All right, next.
The aircraft is 210 kilometers away from the airport on a bearing of 65 degrees.
All right, so stop there. We are going to draw our compass.
No, actually this was 25. It was this the angle that I see they had drawn that looked like one.
What are you arguing about there on your own? What is happening there? What is happening there?
No.
I didn't even argue your things. I was just asking you to confirm.
Now I also got a bit confused. It's
Is it?
25.
Okay. Can we have a 65? So it means you're going to draw a line like that, right? Such that this will be
65.
65.
And it will be 25.
Okay. Next.
The aircraft is
So remember, the aircraft is 210 kilometers from the airport on a bearing of 65. So the aircraft is here. Oh, that's a nice aircraft. Yeah, that's a beautiful aircraft. There. And we know that this distance is 210. Okay, so far, is there anything weird about this? This is simple, right? And you got it. Continue reading. Next.
the aircraft is what is it?
When you read it, what did you say to yourself? Because you did the question, so you must have read it. Or did you just skip it?
I thought maybe I skipped it.
You skipped it. Okay, let's try it. Just give it a go. Say it the way you would want to say it if you were alone. Assume me and Tuapov are not in.
I think you are.
I'm going to kill you if you get it wrong. We are not, right? Okay, so give it a go. Read. The aircraft is really okay. Let me ask: is it that you can't even attempt it, or you're embarrassed of what is going to come out of your mouth? Embarrassed by me and Utapozi. Really? What? Won't laugh at you. Okay, we'll laugh a little bit. No, maybe you're more scared. Okay, she promises not gonna laugh. Me, I am going to.
No, I'm not going.
Okay, I won't. I promise. If I laugh, I give you $10.
Okay.
Yeah. Okay, so let's start. Go on. Okay, let's think of it this way. Maybe you don't want to read it, but do you know what it means, at least? Because maybe you are just scared of reading it because you might get it wrong, the sound of it, but do you know at least what it means in the question? Utopovic, do you know what it means? Mm-hmm.
Just assume that it's like the aircraft was like sent to airport B or something like that.
Okay, so can you read it?
Diverted.
All right, so the aircraft is diverted. So it's to divert is to change the direction of something. Okay, now you can continue with our reading from that
The
sentence.
aircraft is diverted to airport B, which is 130 kilometers away from A on a
Okay,
bearing on a bearing of 215 degrees.
all right, so let's stop there. So we know that the aircraft is going to be diverted to port B, which is 130 kilometers from A, and it's 215 degrees still from A, right? So we still use the same compass, but now we measure 215 degrees. Okay, so how do we make up 215? 90, which is 180. So we just need another angle. So 90. So we just need another angle. How do we get that angle?
215 minus 180.
Okay, 215 minus 180 gives us. So we need an extra 35. An extra 35 here. So I need to remove my A for now. All right, we need the extra 35. It's not a big thing. Okay. So what do we know? We know that this angle is
35
to 215.
no, just that small one that I marked.
35.
35. Thank you. All right. And airport B will be somewhere there. And remember, airport A is here. Okay. Now, choose an appropriate scale and make a scale drawing to find the distance and bearing of airport B from the aircraft. Look what I wrote. I wrote A here. This should be Aircraft, this should be airport B, right? Alright, so can we draw the distance between A and B? Aircraft and B, sorry.
So we.
So it is
Oh,
that, right?
but what if we were to go separate?
But why would you do that?
Because that's the way we would get it. Like, that's the way we would get the triangles. For me.
Okay. Okay, we'll see. We'll see. Maybe it will work. But according to what they want, is the distance between the aircraft and B. So that's the correct line, right? Because now, if we try to go like this, we can go. What if we go like this? What if we go like that? We can go anywhere, right? If we have to now start just deciding whichever way you want to go, like, okay, let's go like that, then the possibilities are endless, because anywhere will reach. But this one, there's
That shape is quite weird.
Is it quite weird? Why?
Makes you kind of feel weird.
It was just a rough drawing and I couldn't.
What's weird about that shape? Is this not a triangle?
Let's use the shape.
Okay, so now let's use the shape, but let's remove now. Let's remove it from this sketch. Let's make it like a simple triangle now. So that triangle will look like what? It will look like this.
Ah, okay.
Okay.
That means the cosine rule. Oh.
Vedavi, you're not here anymore. Let's start with aircraft, port B, airport A. So my first question to you, what is this angle?
Obviously, let angle is in it must the one from what is from 65 coming to 35. So it's 250.
215.
It's 150.
The angle that we're talking about, Vedavi, is this one.
Which one?
From here, going all the way there. Because we can't include this.
Oh, because
It's not part of our angle anymore. So, how do we get it?
so it's
150. Excellent. 215 minus 65, which is 150. Or you can find it any other way you want to know that this is 90 plus the 35 plus the 25 of here. You can still get it that way, right? So we know this is 150. Excellent. Do we know this distance? 210. Do we know the distance of airport B from airport A? Yes. So, what do we have? Two sides, angle that is being formed by those sides, and you want the cosine rule. So is the English of drawing bearings killing you guys? What is happening?
No, for me, I was getting it out like this thing. So that
You got the sketch is nice, but I don't even know what went into your head now to decide, okay, let me try to make triangles. Cosine rule? Okay. So a squared All right. A squared equals to 210 squared plus 130 squared minus 210, 130 cos 150. What do you get?
108,294.284.
284.
0.987.
Okay, so A is
Giving us 329. 329.
329.
Yeah, should we get the point?
Yeah, to the nearest whole number.
Okay, point 1. Oh,
Nearest
no,
whole number.
so,
Yeah.
okay.
So it's 329 kilometers. So that one is settled. Simple and straightforward. I don't know what else can you say. Can you call simple? Okay. From there, the bearing of airport B from the aircraft bearing of airport B from the aircraft.
We draw a compass of it.
Draw a compass at the aircraft. Right? Compass at the aircraft. All right, so far what do we know? We need this whole angle. Okay? So the first two quadrants, they are simple. There is 90 and 90, which is 180. So we just need to know what is this. What is the value of this one? That angle. Okay. Is there a way that can help us to find that angle? You're good.
Let me see. Yeah.
Mm-hmm.
No. Because there was like 135. No, 35. Can it be 35?
Can it be 35? Okay, 35. That would be stretching it.
I think first we should find. No, it wouldn't work.
Maybe we can go back to our drawing here. But it's still the same. Because we just drew a compass here. So we need to know this.
What if we find the angle for
We want to-
AC?
We want to know from airport A.
From the aircraft to airport B.
Oh.
So we want this angle. This whole one. Alright. So let's start with simple things. This is north, right?
Mm-hmm.
And we agree that if we draw a compass, this will be north, right? So if this is 65, which angle will be 65 on the other side? This whole one, right? Yeah, it looks now like it's not correct because I drew it far. Look, there is the Z angle. The Z angle comes
Okay.
like that, and like that, isn't it? So this angle here
65.
is 65. But what we want to know is to know this part only. But at least since we know that this whole angle is 65, if we find this and subtract from 65, we will be able to know this part only, right?
So you're gonna use that.
So,
Sine.
in other words, what we want is to find this angle here. Let's use the sine rule. Sine 150 over 329 equals to sine theta over 130, right? So sine theta equals to 130 sine 150 over 329. Right, so theta equals to inverse of sine for all of that. And 30 sine 150 over 329. $11.39. We can make it round off to a whole number, which is just 11 degrees. 11 degrees?
11, yeah.
Because it's 11.39, we round it off to the nearest one number, so it's 11 degrees. So, we know this angle, it's 11 degrees. And we know the total for the whole angle is 65. So what will be this part alone only?
54.
So this part will be 54. Now, you now have 90 plus 180 plus 54 to get the final bearing. 90 plus 180 plus 54. Because remember, one bearing of the airport B from the aircraft. You want this whole angle.
Oh.
Yes. So we already have 90, we have already 180, plus that part that we calculated, this one that was missing, which is the 54.
234.
234. 90 plus, sorry, it's 180 plus 54. Does it seem to be giving problems, these bearing stories? All right, the curved surface area A of a cone is given by the formula radius minus L, and R is the base radius and L is the slant length. Okay, that is the curved surface area. The volume V of a cone is given by the formula V equals pi r squared H over 3, that's for the volume, where R is the base radius and H is the vertical height. Okay. A solid cone has a slant length of 10, base radius of 6, and vertical height of 8. It is bisected and one half is kept as shown. Calculate the area of the triangular face of the bisected shape. So if we have to just sketch out that triangular shape, what will it look like? It will look like this, right? With a total diameter of 12, which is radius 6 and 6, and a height of 8. Is that what you got on your diagram? Remember, it's saying radius 6, so I just added 6 here and 6 there to make it 12. So to get the area, it's half of base times height.
Giving us 48 centimeters.
8. Where is it? So I decided not to finish it up. What's going on?
I did, but then I did not get to 12.
The thing is that she doubts herself.
Now I'm asking
No,
her
but
how
the
she,
thing
but
is-
then...
No, look, when I said discuss, I did not mean ask for answers.
No, I did not ask for
Like,
answers
for
and
her,
then
she
like...
doubts
Yeah.
herself because she knows the formula.
First
And
of all, before you even go anywhere, where is the sketch at least to show that you are attempting to do something?
Sketch. No, I did not.
This sketch. You see how the sketch helps? The sketch always helps. Just draw it. Then you don't even need to ask it. Asking must be the last resort after your first attempt. Because if you had drawn it, do you see how simple it becomes if you draw it? It's already even given here. Look, if I just extend this line, there is my triangle. Because that's cutting us in half. So I already know that this side is 6. I also know that this side is also going to be 6. So altogether it becomes, this one I already know is 8. So that's the triangle. That's the face that you get. That's the triangle that you get. So sketch it and attempt it. Asking is the last resort. I'm not giving it as a green light, like anytime you just stumble upon a slight problem, then you must ask. No. Only when you really tried to figure it out.
remember that you also doubt herself. You know, you'll know you'll be hearing the formula in the head. And for me, sometimes I write my own things. Just I do. Sometimes I end up doing long voice. I never take shortcuts. I don't know for some reason. Then she will see different numbers and then she gets lost because you start doubting
She
herself, like,
thinks since it's not looking like yours, then it's
Yeah.
not right.
it's not nice.
No. Why are you doubting yourself? You're also afraid to be embarrassed on the page again. But it's even worse now when there's nothing.
But
Then when you actually
I feel like
attempt.
it's the reason why we're here. It's like to get better, and for you to get better, you learn from your mistakes.
Yes.
So it's
And how do you know you have made mistakes? If you have attempted, because if it's blank like this, will I be able even to know where you are getting problems? No, I won't. Here, you have 6 times 8. At least where is the final answer? You decided to just stop there. Where is even the presentation of your work? You know, the presentation where you have A. So I know we're working on question A. That effort is the one I'm looking for. Because if blank, the page is blank, it just shows me that there is not even any attempt at all. So immediately that shows there was no effort. Even if you had put the effort in thinking, but the fact that there's nothing on paper, it somehow shows that there was no effort done, which might not be true. All right. Where is your attempt for part B?
It was this one. The one of
Volume.
Volume.
Of the bisected shape, right? What does it mean, bisected?
Smooth cut.
Cut where?
Now.
Thank you. Cut in half. So which means you're going to calculate the volume of the whole cone, because that's the formula you have. The answer you get, you do what with it? Divided by 2. Where is the formula for volume there? Excellent. What is your R?
Radius.
What is the value of your radius? Okay, start putting things in your formula. V equals to before you even touch the calculator. Okay, V equals to pi, because pi is the value which you will find in the calculator. Where there is R, you replace with what?
6.
Okay, squared. Where there is H, you replace with
8.
8 divided by 3. Use your calculator to... Remember, if you punch like this in your calculator, you're going to have trouble. You have to put brackets in the calculator. Let me see how you're punching it. Okay, let's go. All right.
By 6.
Times. It's better to say times. Whenever numbers are together, it means multiply. Times 8 over 3. So why didn't you do that when you were still alone? You are able to do it now in front of me even, which is even worse, which is even more scary. 301? They say to 3 significant figures there. So it becomes what?
302.
302. Okay. Talk to me.
Isn't that like the final answer to the 3 significant figures?
Yeah, that's the final answer, isn't it?
I don't be dividing it by 2.
Oh, thank you. Pi r squared, pi times 6 squared times 8 over 3. It gives us 301.59. But we want only for the bisected shape. So we find half of that, meaning divide by 2. Divide by 2.
Divided by 2.
Okay, it becomes what? 150.7,
Which means 1.8.
but we want to round off to 3 significant figures, making it 151. Finish off. So the question now is, why didn't you do that? Why didn't you attempt to do that? Because it seems you got it, you know where to find the things. So what is happening? Talk to me. Me, I'm not a page. A page you can ignore to write on it. Me, I want to hear answers. But I'm not putting you on the spot, I'm just asking you. It's a simple conversation. Why? Why didn't you attempt it? Did I tell you where to get these values? No. Did I tell you how the formula? No. You knew that on your own. But why didn't you put it on paper? Are you bored? So what is happening? We're guessing because you don't want to talk to us now. We have to guess. You're not bored. You knew the answer. You knew where to get the values, everything. So what now? Are you being, those bad kids, bad students who just want to show the teacher that, yeah, you can tell me what you want. I ain't gonna do it, man. Is that you can have a bandana for it? Like an American. I ain't doing nothing you say to me. I do what I want. If I want to write, I write. If I don't want to write, I don't write. Is that what you're saying? In other words. So what happened? So is top of his assessment correct that the fact that you feel like you're not confident with your answer makes you not even want to write it out? Is that the correct assessment?
Or do you feel making mistakes?
Or you don't like making mistakes? Or you're gonna make us guess, but yet you know how to talk. Okay, I see. I see. Your boyfriend must have a tough time, Yeah, because imagine when you just decide you're not gonna talk to him, he's just there, baby, and okay, what? Then you're just there. As if you don't.
I don't.
We will not spill our secrets in front of kids.
I don't.
The way she's smiling, she knows something.
She's just smiling like that. I don't.
All right. Calculate the total surface area of the bisected shape. Give your answer correct to 3 significant figures. All right. Before you say anything, let's go back to you. What do they mean when they say total surface area? Show it to me on the screen.
The space is occupied by the thing. The space is...
No, not the bisected shape. Show me this total surface area on this shape.
What is this? The area.
Okay. How many sides does that shape have?
3.
Okay, which one and which one and which one?
This one here.
The triangle, and then the curved part, and then which one?
It's not 2. It's just this one here, the flat one, and this one. 1.
Okay, so it's not sitting down. That shape is floating in the air.
3.
There are 3 sides, eh? So when you have to calculate your total surface area, you have to calculate area of how many sides?
3.
Did you already calculate one of the sides? Look at the shape. Did you already calculate the area of one of the sides?
Did we already calculate the area of one of the sides?
Okay, name the shapes.
Okay.
Name the shapes of this. This shape is called what?
Triangle.
Did you already calculate the shape of the triangle? The area? What was question A saying?
Calculate the area of the triangular face of the...
So already have it, right? Okay. So for the total surface area, we need the triangular face, which you already calculated, and we got 48. Now, what is the shape of the bottom? What do you call that shape?
Semicircle.
Okay. So semicircle shape. All right. What is the area of a circle? You can use your book. This one I expect you to know it very quickly by your head, but I will allow you for now. Area of a circle. But this one I really... Yeah, it's only meant for the I'm feeling left out, which the president doesn't want. Go report me.
Area of the circle.
Hey, it's your book. You must know where your things are.
Is the circle there?
Ravi, I have boxing gloves in my bedroom, so I will take them out and I will not even be ashamed. She will be my witness why I boxed you. It's your notes. You must know where to find your things. It's scary, ne? Because now even if I had given you a test and say you can use your book, you're still not going to find the things because you don't know where they are. What is happening there? It should be somewhere after this because we did area after we did the whole circle story. So a lot of notes were missed here.
You know what? Maybe they're in the other people's.
Oh, maybe they're in the other people. Okay.
Not in my
So I will help you. Utwapovi, what is the area of a circle?
Pi radius squared.
Pi radius squared. Do you see why I'm saying this one you should know it? Because it's so simple. It's just pi radius squared. Can you forget that? With more practice, you will not forget it. Okay. Can you put your things in area of a circle? Pi radius squared. What is our pi? It's pi. What is our radius? Okay. When you put in the calculator, what do you get? I need from you, and I need the answer as to 3 significant figures. Okay, for now we write it out as it is. You see what I told you? If you just punch it like that, it will give you error. Alright.
113.
0.097. For now, we don't round off. 113.0. Okay. And then, so far we have triangular face, which I have shown you, and then we have a semicircle face. This area that we calculated, the 113, is for what? Is it for a semicircle or for a full circle?
Semicircle. No, it's a full circle.
So what do we need to do?
Divided by 2.
Divided by 2, and then you put to 3 significant figures. Okay? 56 point to 3 significant figures, right? So, are we okay there? Area of surface area, we said there is this face number 1. There is this bottom one, which is a semicircle, which is face number 2. What is the last one? The curved part of the cone. Did they tell us how to calculate the surface area of the curved part?
Yeah.
Did they tell us? Did they?
Surface.
Yeah, surface area of the curved part. The first sentence says what? The curved surface area of a cone is given by the formula R times L, where L is the slant length. Slant length is the one that is like this. In this case, it's what? What is the slant length?
10.
Okay. So let's look for the half face. So it's radius times slant length. 6 times 10, which is 60. But that is for the full cone, right? We only want it for half of the cone. So what are we going to do? at the end of the day, the total surface area of that half bisected shape will be putting together that and
56.5 plus 10.
3 significant figures, so it's 135.
Ed, don't listen to her. She's noisy.
56.5 plus 30. You say 86.5
Plus 48.
plus 8 plus what? 134.5.
134 to 3 significant figures.
135.
What's up? Was that so hard, guys?
For me, actually, I only did the previous times. And
Okay, so you did the one for the curved parts.
but the rest, I don't know what happened. Maybe my English was the problem.
Seriously?
Yeah, because I don't know. I just knocked out.
You just decided that the other sides, they don't matter. So one of the clues that I told you guys, ask yourself, am I gonna get 4 marks just by saying 6 times 10 divided by 2? Really? The whole 4 marks just to do this part?
And I actually missed out on that mark. So
Can you see? That's another way of trying to sort of help you. Okay, here I think the work that I need to do is a little bit, a lot. Mark allocation helps you know that. Any question that has at least 3 or more marks, there's going to be a little bit of work involved. Isn't it? It's not going to be as straightforward as you want. And we did total surface area. And we talked about it. What it means. That it means for every side that you can see, that your eye can see. That's why the first question I asked you was, how many sides do you see? Because if you can't see those sides, even when you start putting pen on paper, you won't know where to go. So that's why I always try to say, get the destination first. And the destination is, look at my shape, how many sides do I have, so that I know how many surface areas I need to calculate. And you already knew, you already did the triangular face, so you just needed the bottom one and the slanted one. So, again, not confident. So I wanted us to end the lesson. Are you hungry now? Because I wanted to punish you guys a little bit. Meaning to continue until you get something right completely. Then you can be released. Because I'm failing to understand what's going on here. You don't want to talk to me? The problem is, when we do it together, it suddenly looks easy. So what then?